Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list, published on August 4th, 2025, just yesterday. This paper introduces Qwen-Image, a new model that achieves a remarkable 97.29% accuracy on rendering Chinese characters, a task where other top models often struggle significantly. The paper is titled Qwen-Image Technical Report, and as we'll see, its capabilities go well beyond just text. It also introduces a new method for precise image editing by using a dual encoding mechanism to balance semantic meaning with visual fidelity. Also, the authors shared the implementation on GitHub. If you check it out, you'll find the code, plus some really helpful quick start snippets to generate images right away. They even include instructions for deploying the model and setting up a Gradio demo, which is pretty cool. Alright, so this first figure really visualizes the model's performance. The chart on the left covers general image generation and editing. Across these different benchmarks, you can see that Qwen-Image, shown in purple, consistently scores the highest. But the chart on the right, which focuses on text rendering, is where it truly stands out, especially for Chinese rendering. The performance jump over competitors like GPT-Image 1 is just massive. This result really backs up the claims about its specialized text capabilities. Building on those impressive numbers, this next figure gives us a visual taste of what that performance looks like in practice. Here we see a collage showcasing Qwen-Image's ability to handle complex text rendering. It's not just about single words. For example, we have multi-line Chinese poems in a traditional art style, and even complex English diagrams like the one for emotional well-being. The model seems to handle both alphabetic and logographic languages with really high fidelity across a huge range of different styles and contexts. So how does the model actually do all this? Well, this diagram lays out its core architecture. Its blueprint, really. You can see it's a dual stream design. The left side shows the general flow. A variational autoencoder processes any input image, while the Qwen 2.5 VL model handles the text prompt. These two information streams then get combined and processed by the main engine, which is a series of blocks shown in detail on the right. This dual approach is key to how it aligns visual details with text meaning. This table then breaks down the numbers behind that architecture we just saw. It details the configuration for the vision language model, the variational autoencoder, and the core Multimodal Diffusion Transformer. What really stands out is the scale. The Multimodal Diffusion Transformer alone has 20 billion parameters, which are the internal knobs the model learns, while the vision language model has 7 billion. These massive numbers give you a sense of the model's sheer size and complexity, which is essential for its powerful capabilities. So within that massive architecture, the authors highlight a key innovation. This figure compares different methods for positional encoding, which is essentially giving the model a map so it knows where each piece of information, like a word or an image patch, is located. The older methods on the left would just tack the text on after the image, or squeeze it into one row. But the new approach, shown on the right, called Multimodal Scalable Rope, arranges the text encoding diagonally. This unique placement helps the model better align words with image content. And here's where that advanced positional encoding really pays off. This figure compares how different models handle a prompt for a traditional Chinese couplet. The Qwen-Image result in the bottom right is pretty much perfect. It nails the characters, style, and room layout. In stark contrast, the other models really struggle. For example, GPT-Image 1 misses some characters, while others like Lumina-Image 2.0 can't even render the correct language. This is a powerful visual demonstration of its text rendering superiority. So to wrap up, Qwen-Image really shows that with a sophisticated architecture and targeted training, it's possible to achieve state-of-the-art results in both general image generation and extremely challenging text rendering. This really helps blur the line between perception and creation in AI. That's it for this episode of